Throughout the next lessons, I want to do the final steps of the data preparation for our Bayes classifier and also show you a common format for datasets that you'll often encounter out there in the wild. Over the next lessons, we'll be writing some Python code to create our feature vectors, but not only that, we'll create our features as a sparse matrix. What do I mean by that? Well, let's take it one step at a time. Let's consider a full matrix first. In that case, we have our document IDs in one column, and then we'll have our words in another column. Now, of course, these will be the word IDs, but for illustration, I've written an actual word here on this slide. Then, in that third column, we'll have our label. Our label will be equal to 1 if the email is spam, and it will be equal to 0 if our email is non-spam. So in this case, email number 5795 is a non-spam email, and the label is equal to 0. In that last column, where it says occurrence, we will capture how often the word in the word column appears in the email. So if the word free appears 3 times, then occurrence will be equal to 3. Makes sense, right? The reason that this kind of table is called a full matrix is because for each email, there's an entry for each word, even if that word doesn't occur in the email. The full matrix has an entry for each word in the vocabulary for each and every single email. Now, we set our vocabulary size at 2,500, remember? Therefore, for each document ID, there will be 2,500 entries, many of which will be 0. And this is where the sparse matrix comes in. With a sparse matrix, we will remove the entries which are 0. And that means we actually only include the rows which have a word that occurs in the email. In this example, the word mortgage and the word pay does not appear in email number 5795. Therefore, those rows will not be present in the sparse matrix. So you can see how the sparse matrix is just a compressed version of the full matrix with fewer rows. Now let's head over to Jupyter Notebook and write some Python code. First, let me add a markdown cell to commemorate what we're going to do. We're going to generate features and a sparse matrix. And the first part of that is going to be creating a data frame with one word per column. Now I say creating a data frame with one word per column, but what are we creating the data frame from? Where are we at in terms of our data? We're going to be working with our stemmed nested list. Our stemmed nested list looks like this. So we've got a list of words for each document, for each email. The thing about this is that our stemmed nested list is a series, right? It's a pandas series that holds on to individual lists. So if I was to access the email at position 2, then I would see that even though our stemmed nested list as a whole is a pandas series, it contains individual lists. So it's actually a series of lists. Each entry is a list. That makes it a little bit of an unwieldy data structure. But it's one we're going to work with. And what we're going to do is we're going to convert it from a series containing lists to one of a list containing lists. And the reason for doing that is that there exists a very, very handy method to convert a list of lists into a data frame. So let me quickly copy and paste this cell and show you the method we're going to use to convert our series to a list. And it's simply called toList. Our pandas series has a method called toList, which converts the whole thing to a Python list. Fair enough. The way this looks is what you might expect, namely 2 square brackets, and then in each pair of square brackets, you have an individual email. So the first email ends here, the second one starts here. It's kind of messy, actually. But we don't have to worry about this so much because we're going to create a pandas data frame using this code here. And the way we're going to do that is with pd.dataframe. And instead of the parentheses and then closing it like so, what we're going to do instead is we're going to put a dot and call a method called from records, from underscore records, that is. And this is where we're going to feed in our stemmed underscore nested underscore list dot to list. Now, before I hit Shift Enter on this, let's store this whole thing, this whole data frame, in a variable called word underscore columns underscore df or data frame. And we'll set that equal to pd.dataframe.fromRecords. And then below, we're going to print out the head of this data frame. So word underscore columns underscore df dot head. And let's take a look at the first 5 rows. And what we see here is as the index, we've got our document IDs. We'll add a label for this shortly. And then we have each word split up as an individual data point in a column. And it looks like we have a total of 7,661 columns. The overall shape of our data frame looks like this. We've got 5,796 rows and 7,661 columns. Now here's a question to you. Why does the data frame have this shape? Well, 5,796 is the total number of emails that we have. And 7,661 is the number of words, stemmed words that is, in the longest email. And we know this to be true because we've worked this out in a previous exercise. Now it's time to take the next step, and that is splitting the data into a training and testing data set. It's time to shuffle and split the data now that we've got our word underscore columns data frame. Now, we've actually done this before, so I want to throw this over to you as a challenge. Can you split the data into a training and testing data set using scikit-learn? As you're doing this, set the test size at 30%. That means that the training data should include around 4,057 emails. And also, as you're shuffling, set the seed value to 42. And as you pause this video and try to solve this challenge, have a think about what the target values should be as you're doing this. All right, so here's the solution. We're going to be using scikit-learn's train test split function to accomplish this. So we have to import this whole thing into our notebook. So we'll say from sklearn dot model underscore selection, this is where the whole thing lives, import train test split. Hitting tab on your keyboard after typing a few of the letters should help you avoid any typos on this relatively long import statement. Now hit Shift Enter on the cell, and let's continue where we left off at the bottom of the notebook. The train test split function will give us 4 outputs. So let's store them in 4 separate variables. The first one I'll call x underscore train. The next one I'll call x underscore test. Then lowercase y underscore train, comma, y underscore test. And that's going to be equal to train test split, open parentheses, word columns, data frame. This is going to be our first argument. Then we have to supply our y values. The data frame that we just created, after all, was just the features, right? The different words. The y values that we're trying to predict are actually our categories. And I'm going to grab those from our data frame. It has a column called category, and this is what I'll supply here. Next, I'll set the test size to 0.3, so 30%. And then I'll set my random underscore state to 42. This is where I'm specifying a seed value. And if you and I specify the same seed value, we'll get the same results. We'll get exactly the same shuffle. So let me run this, and then we'll look at our analytics. First, let me print out the number of training samples. And I'll print out xtrain dot shape square brackets 0. These are the number of training samples. And we've got 30% of the total, which is 4,057. Next, let's just verify the fraction of the training set. So the fraction of the training set is going to be this number, 4,057, divided by the total number of entries, say, in our features data frame. So this was word underscore columns underscore df dot shape 0. And that's 70%, or very close to that. Meaning the test set is going to be 1 minus this number, which is 30%, which we've specified here. Now let's take a look at what we've actually got. So I'll take xtrain.head. These are the first 5 rows of our shuffled word underscore columns data frame. Now I said that these numbers here would refer to the index, right? Our document IDs. And we can add this label very, very easily. So we'll say x underscore train dot index dot name is equal to single quotes doc underscore ID. Shift enter. We'll have our index name show up in the output right here. But say we wanted to add this index name to both the training dataset and the testing dataset, so x underscore test as well. We can actually do that in the very same line of code by inserting another equal sign before we assign this string value here and write x underscore test dot index dot name. In this case, we're setting both of these indices equal to doc underscore ID. Let me hit Shift Enter and show you that the document IDs actually match up after shuffling. Let's pull up y underscore train dot head. And there we see the first 5 rows of our target values. And we can see here that the document IDs match up with what we see in the training dataset. Now, of course, that should be true regardless of whether this says x underscore train or x underscore test. The order of the features and the target values will be the same. But proof is in the pudding, right? X underscore test looks like this, and y underscore test looks like this. In the next lesson, we're going to create a sparse matrix from our training dataset. And we're going to do that by transforming the values in our data frame. I'll see you there.